All right, so this is the metric system. As we're introducing different concepts in science, this is one of the most fundamental concepts that we're going to have to do. And so, what is the metric system? It's a decimal system of weights and measures. So we're pretty familiar here in the United States of, say, our measurement of distances in miles or feet or inches. This is slightly different here. We're going to talk about the meter and why this is a beneficial system. We'll also talk about different, besides mass, measuring time, and how that is represented by pretty much the rest of the world and science in general. Okay, so the first thing we have to know about the metric system is everything is in power of 10. This is going to make our life a lot easier. So there are a lot of different systems that you could have. These systems, say a computer system is often done in binary, so zeros and ones, and you can add up to different numbers just using zeros and ones in the placeholders. But a base 10 system allows us just to move the decimal and makes it a little easier. It's an old system here. It was first proposed in 1670. France went ahead and accepted it as its system in 1790s. That's why we call it the SI. It's the what we refer to as the International System of Units. But since the French did it first, it goes by System International, so SI units here. Why this is, to give you just one example of why this is a lot easier, right? So let's say we want to measure a distance. And we want to first, let's talk about miles, right? So if I go 0.4 miles, okay, I would have to say, well, how many feet would that be? Okay, well, I know that 1 foot is about 12 inches. So if I go ahead and take that and multiply it by 5,280, that's a mile. Okay, so 0.4, I would have to multiply that by 0.4. Maybe you can do that in your head if you're clever here or you're good at math. But otherwise, you might need to pull out a calculator and figure out what that is. And then if I say, okay, well, what's that 0.4 in inches? Well, that would probably be a little bit harder to do there. Okay, again, we don't have a nice conversion. Now let's say, hey, I want to know what is 0.4 of a kilometer. All right, well, there's 1,000 meters in a kilometer, so it's a shift of 3. So if I want 0.4 kilometers, that'd just be 400 meters. Well, how many centimeters would that be? Well, that would be 40,000 centimeters. All right. Again, I'm just moving the decimal over. It makes our life a lot easier than having to do those. So our base units here, I pulled this offline. The engineer mindset, just a nice simple table we have here. Length is measured in meter. Time is in second. Mass is the base unit is actually the kilogram here. It's the only one with the prefix of kilo right here. A lot of times, like in chemistry, you'll use gram. But it is kilogram, and the reason why is that it had to do with it's much easier to measure a kilogram. There's actually a weight that they keep stored up that is the reference to 1 kilogram. Temperature. Now, here we often use Fahrenheit. The rest of the word uses Celsius. Neither of these is the base unit. It's actually Kelvin. So Fahrenheit was the first one created. Decent system. But someone came around, Celsius came around and said, "Hey, let's base this off of water. It makes a little more sense." So, 0 degrees Celsius is when water freezes. 100 degrees Celsius is when water boils. That's really nice. It turns out, though, that is not an absolute temperature, right? That's just a reference to water. When we learn that temperature is just a measurement of how matter moves, the question is, well, what happens if matter ever stopped moving? It's theoretical, it can't truly happen. But if that did happen, right, that would be what we call 0K. And then the faster those particles move, it moves up in K here. Now, Kelvin doesn't have degrees. Celsius and Fahrenheit do. But we'll go ahead. This is the base unit here, but we will often use Celsius. Current, luminosity. So current is how much charge passes per second, just measuring the flow of current. Luminosity is how bright something is, often used in astronomy for stars. Amount of substance. So this would just be like saying a dozen, right? But in chemistry especially, this is used because it's 6.02 times 10 to the 23rd. That's a lot of something. Don't have to worry about all these. We're doing a basic physics class here. But those were good stuff. Now, those are our base units. We also have derived units, so units that come from using these units. So like the simplest form we could say is area. If I take a length times a width, well, that's a meter times a meter. That's meter squared. This is a derived unit, right? I'm getting this from something else. There's a bunch of these derived units here. Volume is another one. It's a meter cubed. We could change it to say centimeter cubed for smaller ones. Also, volume, if I'm measuring a liquid, that could be a liter. That is derived. Speed is another one. Acceleration, force. And sometimes our derived units have their own units, right? So these ones, we're still using our base units when we write it out. But a force, we'll learn more about that, is mass times acceleration. And that's a kilogram times a meter per second squared. Well, we have a new unit, and we just breathe the N for the Newton. So sometimes our derived units become their own units and named after the scientists who created them. So just to kind of give you a view of this and why it is really helpful, the rest of the world, they're doing everything just by shifting a decimal. And we'll see that here in the next couple of days of how it just shifts the decimal and makes our life easier. Here in the United States, we are refusing to get off the standard system. And so we are doing a lot more conversions than are necessary. And so, yeah, we make life a little bit harder for ourselves, and it comes up with a lot of errors. So to give you a heads up, if I just go back real quick here, in 1999, NASA lost a $125 million Mars orbiter because half the project used imperial measurements and the other half used the metric. So using that, making a math error there, that was a huge mistake. So next time you're ever in a class and you miss a point on a test, just be glad it wasn't a $125 million mistake there. So the ones we're often going to use here for our physics class is mass, which is in grams, length, which is in meters, okay, volume, which is in liters. Now this is a derived unit here, and time, which is in seconds. Okay, so when we want to use to make these bigger or smaller, oftentimes we will go ahead and we will use metric prefixes. So that's just indicating to us if they're bigger or smaller. So the first thing we need to do is we need to figure out how to read them and how to write them before we do anything else. So I'm just going to give you a couple examples before we talk about all the prefixes. Is if I want to write something is in milligrams, okay, that's mg right here. Well, the first letter we see is a prefix, that's M, and the base unit right here, G, that is my grams, okay, milligrams right there. All right, this one, km, right? So I'm looking at my first one, that's my prefix, and that's kilo, and then M is meter, so a kilometer right here, right there. So let's now take a look. These are my prefixes I can add. My base unit would fit right in between here, okay? And so here's my list of prefixes. Here's the list of symbols that go with them. This is the order, the power they are to, the order of magnitude that they are. And this is the multiplier. So one of the most common ones we're going to use is, let's say, the kilometer right here, or kilo, based up with the meter in physics. So the symbol for that is just K. The multiplier here is 10 to the third. Remember that this is just saying 10 times 10 times 10. Well, 10 times 10 times 10 is equal to 1,000. So really, these two are the same things. But what about when we come to these decimals right here? Well, let's go ahead and look at a milli right here. Milli, the symbol is M. The multiplier here is 10 to the negative 3, right? Well, what does that negative 3 mean? If we think about back to algebra here, that's 1 over 10 to the third. So that would be 1 over 10 times 10 times 10. So that would be 1 over 1,000. Well, 1 divided by 1,000 gets me 0.001, right? Because the first decimal place is tenths, hundredths, thousandths. This is 1/1000th right here, 1 divided by 1,000. So that does still check out even if we get smaller here. So these are all the prefixes I can add to my base unit or my derived unit to show that it's bigger or smaller than the original. So the most common ones we're going to be using in this class are these 6 here, and even the 3 in red are the most common ones of those 6. All right, so we have these right here. I'm going to go ahead and pull up an assignment that we can do to show that we know these. All right, so this is the assignment we have just to make sure we kind of understand this and get the practice we need to feel comfortable identifying these units and then going ahead and writing the prefixes, writing the units themselves, and then also the abbreviations that go with them. So first, let's go list the SI base unit for the following measurements. So that is going to be seconds for time. We measure time in seconds. I know there's a lot more, right? We got minute, hours, days, months, weeks, years, centuries, millennium, all that. But that's all based upon second for the most part, okay? The next one, mass, that's going to be measured in, now, I'm just going to write gram. Now, technically, the mass is measured in kilograms, but I'm going to put grams right here to help us out as we go through this. Distance is in meter. All right, so that's abbreviated with M. And then volume. Okay, we're going to use, for right now, we're just going to use this as a liquid. So that's going to be measured in liters. Right, and we'll abbreviate with a capital L. Okay, so here are the four units that we're going to be using for this assignment right here, just to make sure we understand how to go back and forth here. So convert between the names and abbreviations. So in the first couple, it gives you abbreviations, and we need to go ahead and figure out the name to this. So I have KM right here. So if we go back and remember, the first thing we see is our prefix, and the second one's our base. So it's a K right here, right? So I know that's going to be kilo, right? And then my second one is an M. So I have to go here, and I see that's a meter. So this one right here is a kilometer. Okay, so I make sure I put my prefix first and then my base second. Well, this one's CG, so I have to figure out what was C as my one right here. That's centi right here, right? So that's centi, and then G right here, that's going to be representative of my gram. So that's centigram. Okay, remember, I just look up my prefix first, and then I can add my base. So my base right here is G. I already know what that is. That's gram, right? And that's H right here. So that's going to be, look right here, that's hecto. And this will be then hectogram. Well, this, I'm going to go the opposite order, right? For 8 and 9 are 8, kilogram and centimeter. I want to be able to write these abbreviations. Okay, before we actually do the math manipulation, we have to make sure we understand what they mean and how to go from one to another. So a kilogram right here. Well, we already did kilo right here, so I don't need to go ahead and look it up, right? So that's K, and then gram is just G. So this one I can do a little more quick than the other ones because I'm just putting the abbreviation here. Centi, right? We've already done that one too, right? That's C. And then meter, right? That's my M. So this should just be CM. Right? M, we haven't done that one yet of these. So let's look up what M is on our abbreviation. Well, M is just milli, right? So I'm going to put milli, and then L, capital L is 2 L's there. Liter, milliliter. Okay, you have a drink at home you're drinking out of a bottle or can, go ahead and look on the side of that right now, and you'll see that things are represented in milliliters, right? A pop can might be, 600 and some milliliters or something like that. If you have a 2-liter bottle, right, that'd be 2,000 liters. All right, now we have DM. Okay, I do want to give you make sure when you look at this, right, this is just one D, right, not DA. So then I know it's going to be deci here, right? So deci, and then my next one is M, so decimeter. Write that out right there. Move that up a little bit. Okay, next one. This is a capital M. We have to be very careful on this. So I actually have to go up to this table right here. Notice how I have 2 M's. I have a little m and big M. Big M is for mega, and that's 10 to the 6. All right? 10 to the 6 would be about 1 million here. These top ones that we have right here, these are the ones you're going to be more familiar with if you're into computers or if you are in gaming, right? Your storage, gigabyte, terabyte, megabyte, kilobyte, right? That byte is just a storage of computer information. So how much computer information can you use or store, download at a time, right? So they're your really good PlayStations or Xboxes. They have terabyte of information that they can store on them right there. So mega, so again, capital, we want to go 10 to the 6 here. And this is going to be mega and megaliters here. So that would be a lot of liquid here. Talk about a pool probably at that point. Okay, deciliter. Okay, so we've already used, right, deci right here. That's a little d. And then liter, so DL. And then hectogram right here. So H, we use hecto right there. That's why I know that. And then G. So I went from names to abbreviation to names on these ones. Okay, and then this one, I really just wanted you to get familiar looking at this table here. So write the order of magnitude of the following prefix and its symbol. So if we start with deci right here, I go to deci. Well, deci is, the symbol is D, and it's 10 to the negative first, right? So the power of -1. Now on my system, it's a little difficult in, this is a preview here, to go in power, so I'm just going to go 10 caret. So that's the power of -1 right here. So the symbol is D, caret -1. Right, nano. So let's look up where nano is. Nano is down here. The symbol is n to the negative ninth. Okay, so I'm going to put my symbol first. And then 10, one more space here, to the negative ninth. Now, if I had, remember this really, all these carats are just up to the power of that, right? Kilo, well, we've done this one a few times. Hopefully you know this one by now. That's 10 to the third. Okay, we can go back and look at our chart if we need to. Tera, maybe this one not as familiar, right? So Tera is capital T and 10 to the 12th. Okay, so what would that be numbered? Something we're thinking about? Well, we can always go, a kilo right here is 10 to the third, so that's 1,000. Mega is 10 to the sixth, that's a million. 10 to the ninth is a billion. A tera would then be a trillion. Okay, so I'm going to put a capital T right here, and this is 10 to the 12th. Micro. Okay, this one is not little m. Little m is milli. Well, micro is this symbol right here. It looks a little different. It almost looks like a U with a tail coming down like that in the front. That is not a U. It is what the Greek letter called mu, mu. All right, so it kind of looks like it, but it's not. This 10 to the negative 6. Now, I don't have that super accessible, so save for time, I am going to just use U, but know that it is Greek letter mu, and it is 10 to the negative 6 right here. And last one we're going to do is mega. So mega, that's capital M. We talked about that earlier, and that's 10 to the 6. Okay, so there we go. There are our, went ahead and started with just saying what our units are, the more common ones we're going to use. We went ahead and converted from abbreviations to the names, and then the names to the abbreviations. And then we went ahead and we just looked at our chart and identified these.